Let's talk about s orbitals. For purposes of this discussion, I have moved the helium element to the second column of the periodic table of elements. So in this video, I am going to discuss electron configurations for the first four elements. Now, to come up with a notation for the electron configuration for each of these elements, you need to take the coefficient, then put an s raised to the x. Now the coefficient represents the period in the periodic table, the s represents the orbital, and x represents the number of electrons in a neutral atom of the element. And you have to use this notation for each part of that element's configuration. Now the atomic number is equal to the number of protons, which is equal to the number of electrons in a neutral atom of the element. Configurations are written as you go from left to right across the periodic table and will get longer as you go through the periods. So let's look at some examples. So let's start off with hydrogen. Now reading the periodic table from left to right, here we go. Boom, there's hydrogen. It's in the first period, and here's the s to the 1. So it's 1, s, 1. Now look at the superscript, because that's the number of electrons, which is equal to the number of protons in hydrogen, which is 1. Now let's move on to the next one. Let's move on to helium. Now helium, here we go. Boom. It's in the first period, and here's the s to the 2. So it's 1, s, 2. Now look at the superscript. There are 2 electrons, which is equal to the number of protons in helium, which is 2. Now let's move on to the next one. The next one is lithium. Now lithium, you're going to build from the prior configurations that you've had, and right now we've only had one. And you have to build from the latest configuration in the first period. So if you look at this, you're going to go, boom, finish off this one, which was helium at that time. So it's 1, s2, and then I'm going to erase these so we move on to the next one. So it's in the second period, and here it is, boom, right? So that's 2, and here's the s1, 2, s1. Now, how do you know you have the right number of electrons? You add the superscripts, which is 2 plus 1, which is equal to 3, which is equal to the number of protons in lithium, which is 3. Now let's move on to the last element we're going to discuss here. And that element is beryllium. Now beryllium, once again, you're building upon prior configurations. And here we go. So the first one is, boom, 1, s2. And then let me erase this because we're going to go on to the next configuration. Next configuration is, boom, here we hit it, beryllium. It's in the second period, and here's the s to the 2, it's where it's at. So it's 2, s2. And just look at the superscripts. You have to add them. It's 2 plus 2 is equal to the 4 electrons, which is equal to the number of protons in beryllium, which is 4.